Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. Computing devices come in many shapes, sizes, and levels of capability. They differ in physical form, operating system, processing power, and the types of tasks they are designed to perform. In the CompTIA Tech Plus exam FC0-U71, you will be expected to recognize common categories of devices and know their primary purposes. These categories include traditional systems such as laptops, desktops, and servers, as well as specialized equipment like gaming consoles and newer technologies such as Internet of Things devices. Knowing the different device types, their capabilities, and their intended uses will help you support end users, choose the right equipment for a task, and make sound deployment decisions. Smartphones are one of the most common computing devices in modern IT. They combine communication functions like calling and texting with computing capabilities such as running applications and connecting to cloud services. Smartphones run mobile operating systems such as iOS or Android, and they are used in enterprise environments for tasks like email access, calendar synchronization, and two-factor authentication. Many organizations integrate smartphones with mobile device management systems to enforce security policies, control application installation, and remotely wipe data if a device is lost or stolen. Tablets are portable, touch-based computing devices that sit between a smartphone and a laptop in terms of size and capability. They are used for media consumption, presentations, note-taking, and remote system access. Many tablets support stylus input for handwriting or drawing and can be paired with keyboard accessories for extended productivity. E-readers are a specialized subset of tablets optimized for reading digital books. They use e-ink displays to reduce eye strain and improve battery life. Both tablets and e-readers are used in industries like education, healthcare, and field services, where portability and long battery life are important. Laptops and workstations are full computing systems that combine a processor, storage, display, and input devices in one unit for portability in the case of laptops, or in a desktop form for workstations. Laptops are suitable for mobile workers and students, while workstations are high-performance machines used for demanding tasks such as computer-aided design, video editing, or data analysis. Both allow software installation, connection to peripherals, and hardware upgrades. They are common in business operations, creative industries, and IT administration. Servers are specialized computers that provide services or resources to other devices on a network. They often run specialized server operating systems and handle roles such as file storage, user authentication, database management, and web hosting. Servers can be tower-based for small offices, rack-mounted in data centers, or virtualized in cloud environments. Understanding the role of servers is essential for grasping network infrastructure and how applications are delivered across an organization. Gaming consoles, such as the Xbox or PlayStation, are designed primarily for entertainment and media delivery, but contain many of the same components as general-purpose computers. They include a central processing unit, a graphics processing unit, storage, and networking hardware. While their primary function is running games, they also stream media, connect to online services, and support multiplayer communication. Some businesses use them for testing or as part of employee recreational spaces. Virtual reality systems immerse users in three-dimensional simulated environments, while augmented reality systems overlay digital content onto the real world. These systems use headsets, motion controllers, and sensors to track movement and interact with virtual elements. Applications range from gaming and entertainment to training simulations, architectural visualization, and medical education. The Internet of Things, or IoT, is a category that refers to embedded computing devices connected to the Internet. These devices usually serve a specific function, have limited user interfaces, and operate with minimal human intervention. Examples include smart thermostats, networked security cameras, connected appliances, and wearable fitness trackers. Their small size, focused purpose, and wireless connectivity distinguish them from traditional, multi-purpose computers. Home automation devices include smart door locks, video doorbells, connected lighting systems, and voice-activated assistants. They can be controlled via mobile applications, voice commands, or scheduled automation routines. These devices improve convenience, enhance security, and can reduce energy usage. They connect using protocols such as Wi-Fi, Zigbee, Z-Wave, and Bluetooth. Security and surveillance devices in the IoT category include motion detectors, alarm control panels, and internet-connected cameras. These systems often send alerts to users via mobile applications and may integrate with professional monitoring services. Video feeds and recordings can be stored locally on network-attached storage devices or in cloud storage. These devices raise privacy concerns and must be configured correctly to reduce cybersecurity risks. Wearable devices such as smartwatches and fitness trackers collect health metrics, deliver notifications, and may provide GPS location services. In a workplace setting, wearables can be used for employee wellness tracking, time management, or even augmented reality-assisted tasks. Industrial wearables may include safety monitors or heads-up displays for technicians. Wearables blur the line between consumer electronics and enterprise tools. Medical and specialized IoT equipment includes insulin pumps, connected heart monitors, and smart pill dispensers. These devices collect and transmit health data to medical professionals, often via secure mobile applications or cloud systems. They require strict adherence to privacy regulations, consistent reliability, and robust cybersecurity measures. Knowledge of these devices is important for IT professionals working in healthcare environments. Vehicle and industrial IoT devices include smart automotive systems that handle navigation, diagnostics, and autonomous driving features. Industrial IoT, or IIoT, covers equipment like smart meters, robotic assembly arms, and environmental monitoring sensors. These devices often connect to centralized control systems, cloud dashboards, or mobile applications for monitoring and management. Recognizing these industrial applications will help you understand the diverse environments where computing devices operate. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. In enterprise environments, computing devices are often managed in large quantities, across many locations, and in a variety of categories. Organizations use centralized tools to monitor, configure, and secure these devices. One of the most important categories of these tools is mobile device management software, often abbreviated as MDM. An MDM system allows IT staff to enforce security policies, manage application installations, push configuration updates, and remotely lock or wipe devices if they are lost or stolen. This management capability is critical for smartphones, tablets, and laptops that connect to corporate networks from both on-site and remote locations. Selecting the right device for a job requires understanding the user's needs, the workload, the operating environment, and the available connectivity. For example, a graphic designer working with large image files may require a high-performance workstation with a powerful graphics card and a color-accurate display. A traveling sales professional may benefit more from a lightweight tablet with cellular connectivity. Internet of Things devices can be deployed in smart buildings to automate lighting and climate control, replacing manual switches and thermostats. Matching devices to tasks ensures efficiency and minimizes wasted investment in underused hardware. Interconnectivity and integration are now expected features of most computing devices. Devices often interact using Wi-Fi, Bluetooth, or a USB connection. Synchronizing files between smartphones, laptops, and cloud storage has become routine for mobile workers. In the home or office, smart IoT devices often require a hub or dedicated application to coordinate automation routines, such as turning on lights when a door unlocks. Integration can boost productivity and convenience, but also introduces new layers of complexity in setup, troubleshooting, and security. Embedded devices such as many IoT products, operate under resource constraints. They often have limited memory, modest processing power, and small or non-replaceable batteries. These limitations influence the kind of software they can run, the communication protocols they can support, and how often they can be updated. When maintaining or troubleshooting these devices, IT professionals must work within these boundaries and optimize settings to keep performance stable without draining resources prematurely. Operating systems vary widely between device categories. Mobile devices typically run iOS, Android, or manufacturer-specific variations. Laptops and desktops may use Windows, macOS, or Linux distributions. IoT devices often run lightweight or proprietary operating systems optimized for their specific functions. Understanding the operating system in use helps with compatibility checks, troubleshooting procedures, and integration into existing environments. In some organizations, cross-platform skills are necessary to provide full support. Device lifecycle management is another critical consideration. Every device goes through a cycle that includes procurement, deployment, active use, maintenance, and eventual retirement. During its life, the device may require firmware updates, hardware repairs, and support contract renewals. At end of life, the device should be securely wiped of all data and either recycled, resold, or destroyed according to policy. Proper lifecycle management ensures reliability, cost-effectiveness, and security throughout a device's use. Security considerations vary by device type. Smartphones and tablets are prone to theft and can be infected with malware if not properly managed. IoT devices may ship with weak default passwords, lack encryption, or use outdated firmware. Workstations and servers require both physical security and strong user authentication. Each category of device presents its own risk profile, which must be addressed through security policies, regular updates, and user training. Bring Your Own Device, or BYOD, is a policy that allows employees to use their personal devices for work purposes. While this can improve flexibility and reduce hardware costs, it also introduces security, privacy, and compliance challenges. IT departments implementing BYOD must create clear enrollment processes, monitor for policy compliance, and ensure that work data remains separate and protected from personal data. Scalability becomes a challenge when moving from a small number of devices to hundreds or thousands. IT teams need strategies for automating deployments, pushing bulk updates, monitoring bandwidth usage, and managing resource allocation. The supporting infrastructure, including Wi-Fi capacity and network switches, must be able to handle peak usage without slowing down. Poor scalability planning can result in performance problems, downtime, and frustrated users. Innovation in computing devices continues to evolve rapidly. New trends include foldable smartphone displays, wearable sensors for industrial monitoring, and edge computing devices that process data locally instead of relying on a cloud server. Consumer-grade hardware is often adapted for business or industrial environments. Integration with artificial intelligence assistants and voice interfaces is becoming more common, requiring IT professionals to adapt to new user interaction models. Staying current with these trends is important for exam preparation and for staying competitive in the workplace. Vendor and ecosystem considerations can significantly influence device selection. Some organizations prefer Apple devices for their unified ecosystem. Others may use Microsoft hardware for compatibility with Windows-based enterprise tools, and others may opt for Android devices for their variety and customization. IoT ecosystems can be closed, limiting interoperability, or open, supporting a range of third-party integrations. Awareness of these factors helps avoid vendor lock-in and ensures long-term flexibility in device management. Important glossary terms from this episode include IoT, which stands for Internet of Things, MDM, or Mobile Device Management, VR and AR, which stand for Virtual Reality and Augmented Reality, BYOD, or Bring Your Own Device, as well as workstation, server, peripheral, and embedded device. Reviewing these terms will help you quickly recognize them on the exam and apply them in real-world discussions. In the next episode, we will focus on connected home and business devices in more detail. This will include smart thermostats, video doorbells, security cameras, and wearable devices, explaining how they operate as part of larger IT ecosystems. We will also explore how these devices are installed, configured, and secured, ensuring that convenience features do not come at the expense of security or reliability. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.